That was the distraction.
Don't forget to introduce yourself.
So, we're Team USA on a project called Graphics Card. I'm Jason Banich.
And I'm Ryan DeHaven.
Alright, so the requirements that we chose were to demonstrate control over the Nexus 2 VGA output using the microblade software processor, and also interface with the onboard RAM, and be able to output shapes to a VGA monitor, and use the keyboard in conjunction with a graphical demo. And this is our little system block diagram. We've got a lot of stuff going on here. We've got buttons and switches in case we need them for testing. Keyboard down here goes to UART. G-Drive, LCD for testing on the screen. We had a VGA/RAM controller so we could interface them more directly. And that went out to the screen and to the onboard RAM. And our software diagram was pretty simple. We just initialized it and did a loop over the graphics and the keyboard input.
So this is a design overview. The Nexus 2 is programmed with a microblade software processor, which intermediates the VGA, RAM, and the keyboard. So we just have a section of RAM laid out for 8-bit color, so we get 256 colors to the screen. And RAM holds the pixel bits that are used to output the pixels, and so we can store more of them. And then the WASD keys control the box on the screen for the demo. Now there were some issues with the read for the RAM, because initially we were going to use just an asynchronous read, and that wasn't fast enough, so then we were going to try page burst read, which is also asynchronous, but that wasn't fast enough. So then we were going to use the burst read, which is synchronous, and it seemed to be working, but then we ran into some timing issues. But we have a demo, and it also displays some issues where we have a box being displayed, but sometimes it's kind of cut off in certain areas because of the read. And then we can show you the demo.
Alright, so we're ready for demo now.
So you have your own custom IP core for?
Oh yeah, we use a custom IP core
for the both access to the RAM as well as the VGA.
Exactly. And what we're going to do is we have a 256-bit width bus for the reads and the writes, and what it requires using something like 12 GPIOs to read and write, and we didn't get it working so that we could read and write at the same frame. So right now we stop the display and then write and then refresh the display.
What are you using for the VGA controller itself? HTL?
We're using the HTL.
Import that?
Yeah.
Use that from the digital?
Yeah, we modified those.
Modified it. Sorry.
Yeah.
Any other questions?
Pictures we were talking about. And then also you can change the color with the C button of the background. So that just proves that we did have colors, we just couldn't get them working right. Well, we can get the RAM working right.
The reads. That's basically what's happening.
And the box has bounds, so it can't go out of the screen. Yeah.
And the reason why it flashes like that is it's the way it does an in-out tri-state buffer is kind of weird. I think ours isn't defined properly. There's no documentation on that either, so we didn't know exactly how to do the tri-state buffer correctly for the EEK.
Well, I'm impressed.
Yeah.